The remainder theorem states that if a polynomial is divided by x and x minus a, then the remainder is p of a. So p would stand for the polynomial function. So if you plug a in that polynomial function, you're going to get the remainder. So if the remainder is 0, then the expression is a factor. So that's the same thing as if you divide 6 by 3, you're going to get 3 goes into 6 2 times with the remainder of 0. So that means that 2 is a factor of, or 3 is a factor of 6. If you divide 6 by 4, 4 goes into 6 one time with a remainder of 2. So 4 is not a factor of 6. So the same thing goes with polynomials. If you divide it and the remainder is 0, then it's a factor. So is 3 a factor of 11? So if no, because when you divide 11 by 3, the remainder is not 0. And is 4 a factor of 12? Yes, because when you divide 12 by 4, the remainder is 0. So first example, determine if x equals 4 is a 0. Use the remainder theorem. So if it's a 0, that would mean that x minus, when you plug 4 in for x, you get 0. So I'm going to plug in 4 for x. So 2 times 4 to the 4th plus 9 times 4 to the 3rd plus 7 times 4 squared plus 5 times 4 plus 11. So this is equal to 1231, which is not 0. So is x minus 4? No. A factor? No, because the remainder theorem has p of 4 not equal to 0. P of 4 is equal to 1231. One other way we divide, besides using long division, is to use synthetic division. Okay, so to determine if the expression is a factor. So first what I do is I use the remainder theorem to see what the remainder would be, and then I check it by using synthetic division. So I'm going to use the remainder theorem. So if I'm dividing this polynomial by x minus 1, I'm checking to see what happens when I plug in 1. So I'm going to plug in 1 in for x right here. So it's going to be 1 to the 4th plus 2 times 1 to the 3rd plus 1 minus 3, and I get 1. So I should get a remainder of 1. So now I'm going to set up synthetic division. So with synthetic division, what you want to do is, if you're dividing by x minus 1, 1 is going to be your 0. So you make a big long L. Then you write the coefficients from left to right. So it's going to be 1, 2. Now notice that there's not a term for x squared, so you have to put a 0 right there. And then 1 and negative 3. So that's the first step. Now next step is you want to bring down this number 1 underneath the bar. So synthetic division is, what you're going to do is you're going to multiply left and right diagonally. So 1 times 1 is 1, and you're going to write it underneath the 2. Now you're going to add vertically. 2 plus 1 is 3, and then now you're going to multiply diagonally. 1 times 3 is 3, and now add vertically. 0 plus 3 is 3, and then multiply diagonally. 1 times 3 is 3. Add vertically. 1 plus 3 is 3. And then multiply diagonally. 1 times 3 is 3. Add vertically. So looking back at my answer, I have a remainder of 0, but right here my remainder is 1. So I must have messed up. So I can see right now where I messed up, because 1 plus 3 is 4. So 1 times 4 is 4. So this would be 1. So go back. That's why I'm doing it both ways, so I can go back and check myself. So is x minus 1 a factor? No. And then I actually want to write the solution. So your solution is just not this line of numbers right here. This right here represents the remainder. So because the remainder is 1 and not 0, that's why I know it's not a factor. So going backwards, this is going to be the constant. This is going to be your linear term. This is going to be your quadratic term. And this is going to be your cubic term. Basically, when you do synthetic division, your answer is going to be one less degree than what you started out with. So the answer is going to be 1x cubed, so it's going to be x cubed, plus, this is the quadratic term, 3x squared. This is a linear term, plus 3x. This is the constant, plus 3. So that's my answer. Okay, 3. What I want to do is write out, first find p of 5. So I'm going to plug in 5. So p of 5 is equal to 5 cubed minus 5 times 5 squared minus 7 times 5 plus 25. And I get negative 10. So that means that it's not going to be a factor because my remainder is not 0. So now I'm going to check myself this synthetic division. So I put 5 on the outside, positive 5. I write the coefficients going across. So 1, negative 5, negative 7, and 25. And remember, you need to bring down that first number. And I'm going to multiply diagonally. 5 times 1 is 5. Negative 5 plus 5 is 0. 0 times 5 is 5, or 0. Negative 7 plus 0 is negative 7. And then 5 times negative 7 is negative 35, and then negative 10. So that matches because my remainder is negative 10 in both spots. So is x minus 5 a factor? No, because we had a remainder that wasn't 0. So now I'm going to write my solution. So it started out as x cubed, so that means this is going to be x squared. So it's going to be 1x squared plus 0x minus 7, with a remainder of negative 10 over x minus 5. So I should always write my remainder. You can either put a comma, or actually I'm just going to keep it as minus right here. So I'm going back over here. I did not put the remainder, forgot about it. So it's going to be my plus 1 over x minus 1. So it's always over what you divided by. Okay, example 4. So I'm going to plug in 1. So 1 to the 5th minus 1 is 0. So that means, yes, it's a factor because our remainder is 0. So I'm going to make my synthetic division. So it's going to go 1 on the outside, and then x to the 5th, x to the 0, x to the 3rd, x squared, x, and negative 1. Whole bunch of zeros. So bring down the 1. So 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. Times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. So my solution is going to be, I have to go to x to the 4th. So it's going to be x to the 4th plus x cubed plus x squared plus x plus 1 when I divide it out. Okay, and number 5, if I'm dividing by x plus 2, I'm going to plug in negative 2. So in my calculator, I do 3 times negative 2 to the 4th plus 2 times negative 2 to the 3rd minus negative 2 plus 5, and I get 39. So now I'm going to do synthetic division and see if I get 39 as my remainder. So I'm going to put 3, 2. Now I skipped the x squared term, so I have to put a 0, negative 1, and 5. This is way too big right there. So I'm going to put a negative 2 on the outside. Remember, you have to bring down the first number right underneath it. So multiply diagonally. So negative 2 times 3 is negative 6. Add vertically, negative 4. Negative 2 times negative 4 is 8. Add vertically, 8. Negative 16, negative 17. Negative 2 times negative 17 is 34. 5 plus 34 is 39. So, no, it's not a factor because the remainder is not 0. So my solution is going to be 1 degree less, so it's going to be 3x cubed minus 4x squared plus 8x minus 17 plus the remainder over x plus 2. Okay, number 6, use the remainder theorem for each given polynomial, the polynomial. So what is p of 4 equal to? So if I plug in 4, p of 4 is negative 5 times 4 squared plus 10 times 4 plus 2 is negative 38. So p of negative 2 is 38. So the remainder when dividing p of x by the factor, so if 4 is a 0, we're dividing by x minus 4, is going to be negative 38. Now I'm going to plug in p of negative 2. So it's negative 5 times negative 2 squared. Make sure you plug your negatives in parentheses. So when I plug in negative 2, I also get negative 38. So the remainder when dividing p of x by the factor x plus 2 is negative 38. So neither one of those are factors.